Hi and welcome to day 6 of Python challenge, and today we're going to talk about strings in Python. So without further ado, let's start. So we kind of saw a couple of examples in the previous lessons about strings, so it's not a new concept entirely for us. For example, in this example we assign hello to the string 1 and there to string 2. As you can see here, we use either quotation or single quotation to identify the string. We do a concatenation function on them, and the result will be save on Bob, and when we print Bob we will get hello there. Next example is almost the same. We assign 1, 2, 3 in single quotation to string 3, and we try add 1 to that string and place it back to the string 3. In this case we will get a trace back. The reason is we are trying to add a string to an integer, which is not acceptable in Python. So the way that we can overcome this is we can use the int function and convert the string 3 to an integer. Then we can perform the addition, and when we print the x, is gonna give us 1, 2, 4. So as mentioned, strings are not an entirely new concept for us, and we have dealt with that before. So here are some examples of reading the strings. We use the input function. So in this example we put input and enter column in the single quote. The output would be, we have the enter column and waiting for us to put a string inside it. So we put chalk in this example. We press enter, and the next command is the print command, which will give us back the name that we put as chalk. Here, almost similar example that we had in the previous slide. We assigned 100 to we take the input and we put it on the apple. In this example we put 100 in the apple. When we try to subtract 10 from that apple, we get a trace back. The reason is, again, we are trying to subtract a digit from a integer which is not defined. So basically when we have this input, we always our input command will always take input as a string. Take the input and store it as a string. So we have to be mindful of that. In this example, again, like last slide, we convert the apple to the integer, and when we deduct 10 from it, we will have the result of 90, which is a valid integer. So in this case we don't get a trace back because we are subtracting integer from another integer. So now we want to dissect a string. So there are some basic background that we should have in order to look inside the strings. And basically in this example we have a string called banana, and each character has a location, and the location of this character start always with 0, and so banana is a 6-character word, and we have 0 to 5 to identify each character. So in this example, we assign the string banana with single quotation to variable fruit, and we can identify the character of a string by using a square bracket. So when we put fruit square bracket 1 and assign that to the letter, and when we print letter, we get A. The reason is the location 1 in the string is associated with A, and that's what we get when we have fruit square bracket 1. The other example is we assign 3 to the variable x. We put fruit in the square bracket x minus 1. So x minus 1 will give us 2, and the fruit square bracket 2 means that we need the second character in the string, which will be n. So when we print w, the result would be n, which is the second character in the string. Okay, so here we have another example. We have string ABC. We assign it to Zot, and in this case we are trying to identify the fifth character, the location 5, which is the sixth character of the word of this string ABC. So in this case, because our number is more than the length of the string that we will get a traceback, and the traceback is string index out of range. So basically, in this case, Python cannot find that character, and we get the traceback error. Okay, so we can use another functions in conjunction with strings. So here we're going to use the len function. So the len function will give us the length of the string that we have. So in this example, we assign string banana to fruit. We're going to print the length of the fruit. So the length of the fruit is 6, because we have 6 characters starting from 0. And basically, when we're going to print the length of fruit, we're going to get the output, which is 6. So more about the len function. Basically, what it does is just goes through the string and find the number of characters that is associated with that string. It's a store code basically, so it means that you can invoke this length function anywhere in the Python, and it will take an input and it gives us an output. So in this case, the input of the length function would be a string, and the output of it would be a number, which is the length of the the length of the string. So basically, in this function, we will do some kind of calculation in order to find the length of the string. Okay, now we can use the strings to create loop. In this example, again, we are using fruit variable. We assign banana to the fruit variable. We will define an index equal to 0, and we will have a while loop, which says that while index is less than length of fruit, in this case index is 0, length of fruit is 6 because our banana has 6 character, and so this while block will be run for 6 times, because at the end of this block we're gonna increase our index, so it's gonna run for 0, 1, 2, 3, 4, 5, which is 6 times. So for 6 times we're gonna have we're gonna assign the fruit square bracket index to the variable letter. So basically we start from position 0, then 1, 2, 3, 4, 5, and position 0 is going to be B, and we're going to print index, which in this case is going to be 0, and the letter which is positioned at index 0. So the output is going to be 0B, the next iteration is going to be 1A, the third one is going to be 2N, which is this, next is going to be 3A, next is going to be 4N, and the last one is going to be 5A. So this will be the output of this while loop that we made with the help of string. So here we have a while statement with yellow. The iteration variable that we are using are fruit and index. So we're using fruit, which is a string, and of course we use the len function to calculate the length of fruit string. So this example is kind of a more concise way to achieve the same, almost the same result that we had on the previous slide. So in this example we assign string banana to the fruit. We're just going to say that for letter in fruit, which means that we define our iteration variable here as letter. So letter is going to be our iteration variable. It's going to go from 0 to the length of the banana, basically, which is 5. And for this, for 6 times, because we start from 0, so 0, 1, 2, 3, 4, 5, so we have 6 character. So this 4 is going to run for 6 times, starting from 0 to 5, and we're just going to print the letter, which is our iteration variable as well. So our output is going to be like this. It's going to be basically banana written in this format. So at this point we use the letter as our iteration variable. Excuse me. So as mentioned, it's a bit more elegant and concise to use here if you use the iteration variable inside our for loop. Our code will be more concise, will be more clean, and because we are writing less codes, we have a less chance to make mistake, and of course we have a better chance to troubleshoot our code if there's any problem. And I think the other benefit will be that we will have more optimization in terms of memory and CPU use on the hardware as well. Okay, so now this example is an example of looping and counting at the same time. So here we have our string assigned to word. We define a variable count, assign 0 to it, and we say for letters in word, same as before, and we say if letter is equal to character A, if basically this is saying that if we come across a character A, we're just gonna increase our count by 1. So this means that every time we see, we're gonna parse through this string, and as we go forward, each time we see the character A, we're gonna increase our count by 1. So this loop again is gonna run for 6 times, and after that we're gonna print our variable count, which is gonna tell us the number of times that the character A appeared in our string. So this is an example of using string and loop to count an occurrence inside the string. In this case, that occurrence is the character A. Okay, so just expanding on what was in the previous slides a bit more, going back to our for loops. So here we have for letter in string. So in this case, the letter is going to be our iteration variable, and each time it's going to move forward basically from the position 0 of our string to the last position. So by each iteration, this letter, at the first iteration, this letter is going to be B at the position 0. The next iteration, the letter is going to be position 1 or index 1, which is going to be character A, and this will continue for 6 times, and by each for, inside the for, by each iteration inside the for, we have a print statement, which is going to print out the letter for us. So basically we will have our string written in like vertical line. That will be our output for here. And so again, this letter is our iteration variable. We have 6 character string, which is going to be our sequence. Basically, we're just going to go through this for 6 times. The for block will be the indentation after the for, we can put a bunch of commands here that will run by each iteration of the for loop. And we have the reserved word of in, which is saying that for each letter that we find in this string, we're gonna run this loop for. So that's a bit more dissecting what happened in the previous slides. Okay, again, just going back to that previous slide, we have a flow chart of what's happening here. So at each iteration, the question that this for is asking is that, are we done? If not, we just move to the next letter. So basically we start from index 0, from letter B. We do our whatever commands that we have on our for block, and the next iteration will be our we check if we are done with the string. If not, we just continue forward to the next character, and so on and so forth. When we are done, we just exit out of this loop and we go to the next commands after this block of commands that we have here, but we will get out of the for loops. when we parse through all the characters in the string that we have here. Okay, so now we're going to talk about more operations that we can do with strings. So we're going to talk about slicing. So basically, slicing means that we take, like if we have a long string, we can take a piece of it and print it out or do other operation on that. And for that, you're going to use the square bracket and colon. So here our string is going to be Monty Python. We assign it to S. We're going to use the print function to print the S from 0 to 4. So one point that we have to remember about the square bracket is, so 0 to 0 colon 4 is start at 0. So we start at the first character, which is M. And 4, so it's not including 4 in this case. So this case is starting from 0 but not up to 4. So it's basically starting from 0 up to 3. And this is a bit counterintuitive because here we start from 0 but here we don't end with 4. So it's just a bit of learning that we have to have here, that this example means that the last character is going to be on index number 3. In this example, the last character is going to be index number 6. In this example, because 20 is more than the length of this string, it's going to be 19, but in any case, we're just going to go through the end of it. So this basically doesn't matter if you go till 20 or 19, but the point is the upper limit in our square bracket when we use column operator is 1 less than actual the number that we see here. So here basically we're going to go from 0 to 3, so M-O-N-T, so mont is going to be our output. Here is we're going to go from 6 to 6, so it is going to be only character number and index number 6, which is P, and here is going to be starting 6, which is P, till 19. We don't have 19, is more than the length of the string, so we're just going to have Python as the output of this. So we just have to remember the upper limit is not including the number that we see in the column, in the square bracket. Sorry. Okay, so some more example, some different example, let's say. So if we don't have anything at the start, it automatically starts from the beginning. So it's going to be 0, 1, and that's it, because we are not including 2. So 0, 1 is MO. Here is going to be 8 column and square bracket, which means to start from 8 to the end of the string. So 8 is here, THON is going to be our output, and here we're just going to have from the beginning to the end of the string. So we're just going to have Monty Python here. Okay, we can do concatenation. Again, this is not a very new topic here. We talked about it before. Here we assign string hello to A. We gonna use the concatenation, the plus operator, to add A to there. We're gonna print it. We're gonna have hello there. So because there was no space here at the end of hello or at the beginning of there, this is just going to be a complete concatenation. Basically just going to give us hello there. If we want the space between, what we can do, we can have a plus single quotation space single quotation and plus there, and then in print this we're gonna have the space between hello and there. Okay, so we're gonna talk about using a logical operator. So here we have our string assigned to variable fruit, and we're gonna say that single quotation n in fruit. What does this mean is there any character n in our string? And in this case we have 2n in our string, so the result of this would be true. The next example is this one. So what does this mean is that do we have a character m in our string? And in this example we don't have any m, so the output of this would be false. The next line is going to talk about, do we have a nan in our string? We do, so the result would be true. And here we use the same concept in a if statement. So if character a exists in fruit, we're gonna type, we're gonna print found it. And because this is a true statement, we do have a in our string, we're gonna come to this block and we're gonna run this print, and the output would be found it. So here we use the string, I'm sorry, here we use in as a logical operator. Okay, so here we talk about comparison. Basically we're going to talk about double equal sign, less than equal sign, and greater than equal sign. So in this case basically what we do is we check is our string is lexicographically higher, lower, or equal to another string. So for example, as far as I know, and I might be wrong, so don't take that, I mean take that with a grain of salt. I believe the small characters has a higher lexicographic value than uppercase character. So basically based on those lexicographical value, we can do some comparison. Are they equal? Is one smaller or greater than the other string? So we can have those comparison as well with this inside the strings as well. Okay, so the other point is string library. So basically we have some functions that are associated with the string, so we can call those functions on our string. The way that we call it is, for example, we assign a string to a variable and we call those functions with the dot. So we have our variable which is assigned to, which has a string inside of it, and when we call dot lower parentheses, what it does is this function will convert our string to the lower case. So when we print it, we assign it to another variable. When we print it, we get our identical string but in lowercase. The important thing here is our original variable, basically our original string did not change. So if we print our original string, we still get that uppercase values that we initially had in the string. So it's just going to change for this new variable that we assigned the lower function to. We can call our function with the dot directly at this string as well. So here we have a string identified with the single quotation, and at the end of it we bring dot lower parentheses, and this will make our string lowercase and prints it here. So we're going to talk about a couple of, so in this example, yeah, basically we have a list of possible functions or method, let's say, because when we use the dot here, and let's go back to the previous slide. When we use the dot here, we're kind of going to the object-oriented design. So the dot is when we have dot, we will treat this variable as an object. So these are basically called the methods that we can call upon our strings, and we will get to know all of them in our duration of our career, hopefully. So just be aware that we can call those methods by using the dot operand at the end of our string, and in that case our string will be considered as an object. Okay, so just a couple of other methods that we can have with their definition, basically. And again, some more method with the way that we can use them. We can invoke them if they take any other input, what kind of input they take if they do, and yeah. Okay, so the other function that we can, or let's say method that we can do, is the find through the string. So here we assign our string to variable fruit, and we're gonna say that fruit dot find, in the parentheses we have a string NA. So basically what it does is gonna find any it's gonna find the position. So this function, this method is gonna find the position of this string, this substring, let's say. So it goes to the string, it looks for NA, it finds NA, and the location of it, this is 0, 1, 2. So the output of this would be 2, the location of first NA inside our string. Here we try to find for character Z. Character Z does not exist in our string, so our output is going to be -1. So -1 means that this substring was not found. and we will return -1. Another reminder that the string index always starts at 0. Okay, so now we're gonna use another example, which is upper method. So we assign our string to the variable. We say variable dot upper parentheses. Then we print that our string is going to be converted all to uppercase. The opposite of this function is dot lower parentheses. When we add it to the end of our string, or the variable that is holding our string, and what it does, it will convert everything to the lowercase. Search and replace function. So in this case, we have hello Bob assigned to variable greet. We do call the method replace upon the greet variable, and we say that if you find Bob, replace it with Jane. So we save that on the NSTR. When we print NSTR, we see that Bob has changed to Jane because of this search and replace function. Another example with the same string, we're going to replace character O with character uppercase X. So here we're going to have this replacement here because of this search and replace function. So this is for, we have some functions to strip the white spacing. So if there is a space at the beginning here, you see we have some space at the beginning of our strip of our string. We call left strip function, and the output would be our string without the left space says that it had, but it still has its spaces at the right side. We call this other function, which is rstrip. So it's going to strip the right portion of it. So you see the output would be the right portion of our string doesn't have the space anymore, but the left side still has it. And if we call the strip function, it's gonna basically strip the spaces at the beginning and the end of the string, and it's gonna give us hello Bob without any spaces. So prefixes. Here we have another method which is called start with. So we have our string assigned to line. We say line dot start with please, and because this string start with please, the output would be true. We do the same thing with small character p, but because our string starts with capital character P, the result would be false. So our string does not start with this small character P. Okay, so we're gonna do some parsing and extraction. Our data is this long, relatively long compared to what we had before. String. We're gonna find the location of @. So this is our string, starting from character 0, going all up to @, which is at 21. So the print of this would be 21. We're gonna find space, the first space, starting from position that the @ sign was. So you start from here, you don't start at the beginning. You start from here and going forward, we want to know the position of the first space, which is 31. So we can the find command, the find method has another, we can use it with another input, and that is the location that we want to start our search from. So at this example, we didn't start from the beginning, we start from the location of @ sign. And here we have basically we're going to extract a piece of it. So we're going to have data, we're going to use the square bracket with the column. We're going to start at position of @ sign +1, which is going to be 22. So starting from this till the position 31. So as you remember, it does not include 31. It includes the whatever we have here, but it just doesn't include the end of it here. It goes one below that, which is going to be position 30. So this will give us whatever we have after the @ sign. So this will give us the University of South Africa, University of Cape Town in South Africa, domain, basically. So that's how we use parsing and extracting. Okay, so we're going to talk about a little about how Python 3 and Python 2 are different. In Python 2, if we had a Korean character, it would be and we would assign like some operation to it, the end result would be considered as a Unicode. So that's in Python 2, but in Python 3 we have them as string. So this is kind of like differentiating between Python 2 and Python 3. Summary. So what we talked about the type of string, we talked about how to read, convert, we talked about to index them, we talked about how to slice them, we talked about how to loop through them using for and while, we talked about how to concatenate them, we talked about some other operations, libraries and functions and methods. We talked if we can use the comparison between strings. We talked about how to search in strings and replace in strings, and how to strip white spaces in our strings. Yeah, so thank you for listening. This slides was done by Dr. Charles Severance, and we have to give credit where it's due. Thank you for listening, and hope to see you on the next video.